word it, but wouldn't you put like a 1 in front of the x's and then divide?
Yeah. So what is
Yeah.
the equation of that?
Y equals 1.
Y equals 1. So again, you probably want to graph that right away. And then I mentioned putting these arrows at the edges of each of these because we're going to connect them later on. All right, so then the third and or the I don't know, fourth and fifth things we'll say were intercepts. Okay, so let's start with the I guess we did x-intercept. It doesn't really matter. Do you remember how to find the x-intercept of this equation?
You set the numerator to 0.
Yes. So you said x minus 2 equal to 0, and you get x equals
X
2.
equals 2. Yeah.
And that's a point there. Then the y-intercept. Y-intercept. Do you remember what you do for that one to find the y-intercept?
I know you set x to 0, but do you set both of the x's to 0?
Yes, you put 0 in for x.
So is the x-intercept negative 2/3, or x equals negative 2/3?
Yes, and y is 0. Or I'm sorry, and
Okay.
I'm sorry, x is 0. You're setting x equal to 0, and y equals negative 2/3.
Okay.
Okay, and that's another point here. All right, so now you connect the points on the curve. So you're like, oh, if I got to connect these two, it must go with this one up here. And then we talked about the parent function looking like something like this.
Yeah. Okay. I think I got that.
All right, so let's try one more here. This is a slightly different type of problem, but it's in the same sort of category. So let's say you were given 1 over x minus 1 plus 3. Okay. So this one's slightly different, but this is within the category of problems that you might see. Okay, so to find the domain, you do the same thing. You set the denominator equal to 0. So you set x minus 1 equal to 0, and you find that x cannot be 1, like you said, minus infinity to 1, union 1 to infinity. Okay.
Yeah.
Vertical asymptotes are exactly the same. Okay, so you have one here at x equals 1. So when we go to graph this, there's your vertical asymptote. Okay. This is where it gets a little bit different for horizontal asymptotes. Okay. The horizontal asymptote is this number off to the side. Okay, it's this 3 right here. That is your horizontal asymptote. Okay, but again, notice that this is different than the previous problems. Previous problems we just had a function in the top and the bottom, maybe a number in the top, but now there's a number off to the side here. That is your horizontal asymptote. Okay, so it has nothing to do with those 3 cases that we talked about, because this is now in a different form as those 3 cases. So we write y equals 3, and that is the horizontal asymptote here. So you can again draw those little arrows if you need to. I think they're pretty helpful. Okay, and then the next thing we're going to do is the x-intercept. So the x-intercept, normally you set the numerator equal to 0, right?
Yeah.
But more generally, what you're doing is you're setting f of x equal to 0. You're setting the whole left side equal to 0. So that's 0 equals 1 over x minus 1 plus 3. And you have to be able to solve for x. Any idea how to do that?
Wouldn't you start out by subtracting 3 on both sides?
Yes. So you'd have negative 3 equals 1 over x minus 1. And then do you have any idea how to solve from here?
Divide by 1.
So you have to get the variable out of the bottom.
Yeah.
And the only way to do that is to, I call it cross multiplying. Some people call it diagonal multiplying, butterflying. You got to multiply diagonally.
So would it be negative 3x plus 3 equals 1?
It's considered in parentheses, -3 parentheses x minus 1 equals 1 times 1.
Okay.
So you have negative 3x plus 3 equals 1.
And then you just solve for x.
Yes. So go ahead and solve this one for x for me.
Would it be x equals 2/3?
Yes, that looks right. Okay. All right, so a little more work there, a little more work to do. You have to set it, but that gives you another point. Okay, it's 2/3, x is 2/3 and y is 0. So right there, roughly. Okay. Your fifth thing is to find the y-intercept, and that's when you set x equal to 0.
So that would be positive 1.
So you're putting that 0 in for x.
Oh, negative 1.
Yeah, it's 1 over 0 minus 1 plus 3.
So positive 2.
Yes, positive 2. Okay. And there you go. You got a couple of points there. And you can start connecting the graph here. Okay, so let me give you one to try. I'm just going to have you find the x-intercept and the y-intercept of these. So let me give you one. Let's say f of x equals -2 over x minus 3 plus 5. Actually, I don't like that one. Let me go -6. Okay. Yeah, go ahead and find the x-intercept and the y-intercept for this one.
Okay, set the numerator to 0. So you'd put f, so you'd set f of x to 0 for.
That's right. F of x equal to 0.
-5 minus 5, -5 equals. And then you do the cross multiply thing, right?
Yes.
-5x. Oh, wait, yeah, I have to do it in parentheses. I'm not sure if this is right, but I think I have an answer.
Okay, go ahead and give me your answer.
X equals 21 over 5.
Okay, so let's check that here. So you set f of x equal to 0.
Yeah.
And you already told me this. You move the 5 to the other side. So you have -5 equals -6 over x minus 3. Divide by 1. So you're going to cross multiply -5 parentheses x minus 3 equals 1 times -6 minus 5x plus 15 equals -6. And yeah, when you manipulate this from here, you're going to get -5x equals -21, or like you said, x equals 21 over 5. Good. Okay, try finding the y-intercept.
Would it be y equals 2?
Yes, I'm sorry, nope, that is not correct. So did you put 0 in for X?
Yeah.
Okay, so like something like this off to the right here, -6 over 0 minus 3. -6 over -3. That is 2, but what about this
Oh,
+5?
it'd be +7.
Yes.
Yeah, I ignored the numerator.
Yeah, you can't give up on this stuff. Okay. So we're about to get to holes, but I'll just make one final point here is that like the things I just showed you, like let's say you had a problem like this, x minus 2 over x plus 3, like that. To find the x-intercept, you're still setting f of x equal to 0. You're still going 0 equals x minus 2 over x plus 3. Okay. But the only way this is 0, the only way the thing on the right hand side is 0 is if the numerator is 0. So that's why you only set the numerator equal to 0. It's sort of a shortcut, but it always works.
Yeah.
Okay. All right, so let's talk about holes. So let's say f of x equals x minus 1 over x squared minus 1. Okay, and the instructions are basically to graph this like we've been doing with all the others. So the first thing you always do in these is you always factor. And there's like all these different types of factoring you're supposed to have learned. Okay. Do you remember what the bottom is in terms of factoring? What type that is? It's got 2 terms.
I don't remember the type, but it'd have 2 x's. Or no.
So one of them is called difference of squares, and that's what this one is, difference of squares. And if you have an a squared minus a b squared, it's always a minus b times a plus b. Do you remember seeing that?
Yeah.
Okay, and there's a bunch of different types of factoring you might see, but we'll start with this one. So the reason you have to know all these factoring is so you can manipulate the equation. So the bottom becomes x minus 1, x plus 1. Is that okay? Is that clear?
Yeah.
Okay, now do you agree that the factors are going to cancel? That
Yes.
x minus 1 cancels x minus 1. What is left over in the numerator?
0.
Okay, if it were 0, then the whole thing would be 0 up top, wouldn't it?
Yeah.
So what do you multiply? What do you multiply by to remain the same? What number do you multiply by when you want to get the same thing?
1.
1. So there's an implied 1 in the numerator. So this becomes 1 over x plus 1. Okay. So that part we got to get really, really clear. But there's a hole at x minus 1 equals 0. Okay, it's the factor that cancels. That's where there's a hole.
So a hole is a factor that cancels.
So because x minus 1 canceled, there's a hole there.
So the hole would be x minus 1.
No, it's at x minus 1 equals 0. We have stuff to solve for x. The hole is a point. Let's make that clear. Is a point. It's not a literal point because there's nothing there, but it's a place that you'd like to be there on the curve, but it's not. Okay, so you solve for x. You set x becomes 1. All right. So now you have to find the y value. To get the y value, you put x into the reduced function. So you're going to put this 1 back in here.
So it'd be 1/2.
1 over 1 plus 1, which is 1/2. So now you have a point. X is 1, y is 1/2. Okay, so now let me go ahead and graph that for us here. 1 and 1/2. So I like to make it really clear that that's a hole. 1 and 1/2, like you really want to show a dot that's not filled in because that's what your instructor's expecting. So you asked, and we should go back and work on either this problem or similar problem, but a hole is only one part of it. It's only one little piece. Okay, you still are supposed to find the domain of this function. Okay, so let's start fresh here. Let me rewrite the function. And I'll show it in the expanded form and then the reduced form here. Okay, and we'll talk about how it is. So the first thing is the domain. The domain comes from setting the denominator equal to 0. X squared minus 1 equal to 0. Not the reduced form, not the reduced one, the original. You have to set the original equal to 0. Okay, so when you factor it, you get x minus 1, x plus 1 equal to 0. So now you have two places where it's equal to 0. So x cannot be 1 and x cannot be negative 1. Oops, that's positive 1 to infinity. So something like that, 3 intervals there. Give me just a moment, please. Be right back.
Okay.
All right, so that doesn't affect any of the graphing that we've done. So what did we normally do next? We normally did vertical asymptotes, but the second thing you actually find are holes. So this is very important. Holes are before asymptotes. Okay, so we found our hole. The third thing you find are vertical asymptotes. So you set the denominator equal to 0, but this time it's the reduced form. You set the reduced form equal to 0. So I hope this isn't too confusing, because it's like they misled you initially. They're like, don't worry about holes. Now you got to worry about holes. That reduced form is where you have to set equal to 0. So you set the denominator equal to 0, that x plus 1 equal to 0. So that's x equals minus 1. That's your vertical asymptote. Horizontal asymptotes are next. You still with me there, Jadon?
Yeah.
Okay.
I'm just getting this down.
Yeah. Let me know if I need to pause so you can get everything down.
Okay. Horizontal asymptotes.
So horizontal asymptotes, you want to use the reduced form. You're looking at the 1 over x plus 1. This is that case number 1 where the degree of the numerator is less than the degree of the denominator. So this is y equals 0. Do you remember us talking about that the other day?
Yeah.
Okay, so again, another kind of dashed horizontal line, put some arrows. Okay. So now we move into x-intercepts. So x-intercept is setting the whole thing equal to 0, setting 0 equal to 1 over x plus 1. But more generally, it's setting the numerator equal to 0, but you can't set 1 equal to 0. That's an impossibility. So this one has no x-intercept. Y-intercept comes from setting x equal to 0. So you put 0 in for x, 1 over 0 plus 1, and that gives you 1. So we put that point on the graph. And now you connect. You're like, all right, how can I connect? I can't cross the dashed lines. So I'm going to go down, boom, hit that point. I don't go through the hole, but I connect with it. And then because of the parent function, it goes like that.
I got that. So you'd always use the reduced form.
You use the reduced form for everything after holes.
Okay.
For domain, you got to go back to the original. So I like to keep them all around because it's like one form is better than another. You'll see that when they get more complicated. It's like which one do you want to use for it? Yeah, it feels like a lot. I mean, but you do this a bunch of time, you're like, all right, the like domain leads to intercepts, or I'm sorry, domain leads to holes and vertical asymptotes. You get your horizontals, then you get your X and your Ys, and you connect the dots. Okay, not an impossible thing here. Okay, let's look at another problem here. Let's say f of x equals, let's go x squared minus x minus 6. And we'll go x plus 2 in the numerator. Okay, so the first thing you want to always do here is you want to factor. So there's a bunch of different types of factoring. We've already talked about difference of squares. This is considered an a equals 1 trinomial. Okay, and there's a certain like method of factoring. So do you remember how to factor the bottom?
Yeah. Let me see if I can try to do it. So it would be x or parentheses x minus 2 close parentheses x plus 3.
Okay, so if that were true, and this is what you said, when you FOIL it, you should get back to the original. So when you FOIL it, you get positive 3x minus 2x minus 6. You get x squared plus x minus 6. Is that what we have written there?
Oh, no.
No. So what do you think your mistake is? Because 3 and negative 2 definitely add up, multiply to negative 6, but they don't add up to negative 1.
Is one of the x's negative? Or wait. Is it positive 2 and then negative 3?
Yes, plus 2, x minus 3. Good. Okay. Great. So you don't cancel, you just factor. So you factor because it helps you figuring out things like domain and then holes and vertical asymptotes, but don't cancel yet. Okay, so the first thing you want to find is the domain. So I'd like you to try finding the domain for me on this one.
It'd be negative 6.
The domain?
Yeah.
The domain is a set. The domain means where's the function undefined? We've been doing it in interval notation.
Oh, x can't equal negative 6.
Okay, so you're saying negative 6 makes the bottom 0. I mean that is what you meant by that. So let's review here. When you set the bottom equal to 0, what it means is that either x plus 2 is 0 or x minus 3 is 0. And that's they call it the zero product property. You don't need to know that, but you need to know to set each factor equal to 0.
Oh, okay, that makes more sense. So x can't equal negative 2 or positive 3.
Okay, so how would that look in interval notation?
Yeah, let me go back here.
So what some students do is yeah, go ahead.
Negative infinity to negative 2 in union with negative 2 to positive 3 in union with 3 to positive infinity.
Good. So there's your domain. It's a little bit more work, but you do have to set each of those equal to 0, each of those factors. Okay. So after domain, that's when you go to holes. And you look for holes. They don't always have holes, but in this one they do. Okay, so the holes are where the factors cancels. Which two factors cancel?
X plus 2.
Right. And then what's left in the numerator?
1.
1. Okay, so there's your reduced form. So I like to write it this way. I like to go hole at, and it's the factor that cancels. It's the number for X where the factors cancel. Okay, so it's that X plus 2 equals 0. It's wherever that cancels. So you have to find that X value, but it comes from that factor that cancels. You ignore the other one for the moment.
Yeah, my math teacher likes writing holes as, like, for example, this hole would be X equals -2.
Yeah, well, we want to do that. We want to do that. We want to say X equals -2, but I'm trying to show you the equation that you're using to find it.
Yeah. Yeah. Okay, I think I got that.
Okay, but that's only part of it because the hole has an X and a Y value. Okay, so what is the Y value? Well, you get the Y value by putting that X back into the reduced form.
So, -1/5.
Yes, Y is -1/5. Okay. All right, good. So that's really like what we would start by graphing. I guess I'll do it over. We would start by graphing vertical asymptotes, but you actually do the holes first. So -2, -1/5. So you put a big, you overdo it. You say it's right there, overemphasize it, -1/5.
Okay.
Okay, and now we move back to vertical asymptotes. Where does this one have a vertical asymptote? And if you're looking at it, you want to look at the reduced form.
Hang on. X equals +3.
Yeah, so that's the equation of the line. X equals 3 right there. Boom, we got it. Then you want to do the horizontal asymptotes. So you go to the reduced form again. You go to this one right here. What is the horizontal asymptote?
Y equals 0.
Equals 0. Yeah. So we're starting to fill in this graph here. Here we go. Y equals 0. X equals 3. So maybe some arrows. Yeah. Okay. Now from here, we find the x-intercept or the y-intercept. It doesn't really matter, but you use that reduced form. So does this have an x-intercept?
No, it doesn't.
It does not. So there's none. Sometimes you can say an NA. Y-intercept.
So it'd be 0, -1/3.
Yeah, perfect. Okay, and that's a full legitimate point there. Now you might be some students, that's -1/5, that's -1/3. I mean, the -1/3 needs to be slightly lower than -1/5. I mean, may not be possible. I write big, so it's hard for me to show that. But those always connect, and then you can't cross the dashed line. So you have to connect your graph up this way. And then because of the parent function, it's in the other quadrant there.
Okay, you got that?
All right, so let's look at a new problem here. Let's go x squared minus 9 over x squared. Sorry, I'm trying to come up with the numbers here that work without writing anything down. Okay. Let me go that way. Okay. All right. I'm going to step away from the moment. I want you to come up with the domain, if you can, holes and the vertical asymptotes on this one. And the hint here is that you need to factor both the numerator and the denominator. But I'll give you like 2 minutes, 2 or 3 minutes here, and I'll check back with you. But I'll be right back.
Okay.
Any questions for me, Jadon, on this one?
No, I got the domain.
Okay, what's your domain?
Negative infinity to negative infinity to -3, and union with -3 to +4, and union with 4 to positive infinity.
Okay, so did you factor the numerator and the denominator?
Yeah.
Okay, what did you get in the numerator?
X plus 3 and then x minus 3.
Okay, and what about in the bottom?
X plus 3 and then x minus 4.
Okay, so we got a problem here. So when you FOIL this on the bottom, you're going to get x squared minus 4x plus 3x minus 12.
Oh, yeah, I wrote the equation wrong. I wrote negative x instead of positive x.
So it should be minus 3 plus 4. Okay, and
Yeah.
then you know that does affect your domain. That really does. So that's why the factoring, you know, they don't do a good job of explaining, when am I going to ever use this factoring? Well, you know, you use it over here. What did I do here? Yeah, that's right. Okay, so give me the domain again now. Now that you've made this adjustment. And sometimes it helps to you know, label the 2 points where it's no good.
Okay, negative infinity to +3 in
Nope.
union with.
Nope, you guys start at the -4. You gotta,
Oh,
yeah.
negative infinity to -4 in union with -4 to +3.
Good.
In union with +3 to positive infinity.
Yeah. So I put up a question of the day on my social on Instagram, and one of the what I always do is I always mix up these numbers. And if you're taking the SAT, ACT, that's the kind of answers you should expect, where, you know, there's one with a -3 or a +3 or 4. So you really gotta, you know, pay attention to the details there on that. All right, good. Okay. I'll give you another few moments to figure out the holes in the vertical asymptotes if you need it. What did you come up with for your hole?
I haven't finished it yet, but there's a
Okay.
hole at x minus 3.
Right. So we would turn that into x equals 3. And then
Yeah.
you want to use the reduced form now to figure out where the y value is. You have to find the y value. It's not good enough to just find the x value.
Would the y value be 6/7?
Yeah. Yeah. Now, if this were a test or quiz, I'd probably come up with ones that were a little nicer than fractions, but that is the nature of these things. You sometimes can't figure it out. Okay. Now, how about the vertical asymptote?
I'm working on that one right now.
Okay, great.
X equals -4.
That's right. And let's finish it up here with the, let's go horizontal asymptote. Use the reduced form.
So it'd be y equals 1.
Y equals 1, good. And let's do the x-intercept now. So because it's a fraction, you can just set the numerator equal to 0.
Oh, whoops.
So hopefully you're setting x
Would it
plus
be
3.
would
Go
it be 3/4?
That's the y-intercept.
Oh,
The y-intercept is when you're setting x equal to 0. Yeah, that is 3/4. But the x-intercept, you're just setting the numerator equal to 0, -3. Let me know when you get all that down, Jadon.
I got that.
Awesome. So I mentioned before, normal lessons are 50 minutes. So we're kind of right at the time, 2 40-minute lessons for getting us caught up on everything. These problems take a while. So you're not going to get like 10 of them on your test. You're going to get a couple. And
Yeah.
that's why you got to have like every part's got to be like really well known. That way you can knock it out. So I'm glad to see you were willing to do some lessons over fall break. I think you got a lot out of this. I can kind of see some areas where I'll definitely want to like work with you a little more on like, switching between X and Y intercepts, stuff like that, giving you more of the practice to figure that out. So if you have the time, definitely go back and look at the YouTube, look at the notes, and that's it for today.
Okay.
So thank you very much. I'll send you an email here shortly with the notes, and be happy to help you again in the future.
Thank you.
You're welcome. Have a great day. Bye now.
You too.